So I get to introduce Gabe Schuyler, who is with a small but well-known cloud security company named Wiz, and he's been doing cloud sec stuff for quite a while, helping people secure their content and their data in the cloud. And I guess an interesting thing from the CFP, and I think it made it into the public bio, is that Gabe has named computers. He's got the like, I don't know, I was just chatting with him ahead of time. I think it's sort of like an emotional support computer that's like always with you at all times, close and cuddly and that sort of thing. So I thought that was a fun little tidbit about Gabe. But with that, please take it away.
All right. Thanks. Okay. Yeah, it's true. I do have a little computer that I carry around with me when I'm hacking stuff, but it's so small and it has wonderful little stickers on it and a Care Bear desktop that it's totally harmless. All right, so yeah, this is Trending Cloud Security Threats and Defense. If you're looking for something else, you're in the wrong room. And here's a little bit about me. I do hail from Austin, Texas. I do work for Wiz. I am not working for them today. I'm on PTO, so doing my own thing. I'll also mention that I used to work for Palo Alto Networks and Puppet Labs and PlayStation. Actually, I'm in the credits of like 20-something video games. Been doing operations forever, InfoSec for a bunch, automation for as long as I can think of. I am curious about you folks. If this picture looks weird, it's because it's Stable Diffusion. I told it to show me a hacker typing on a typewriter. I don't know. It's close enough. So I'm interested to know the depth of knowledge about the cloud. I specifically set the technicality dial to not even half, so that introductory folks, you should be able to keep up. If you don't, interrupt me. Who here has stuff in the cloud? At least, okay, yeah, that makes sense. Is anybody here like cloud native? They only have stuff in the cloud. All right, cool. That's happening more and more. My work is entirely in the cloud, so that's pretty cool to know that some of y'all are actually doing that. Here are some basics about cloud security just to get you up to speed. And this is what Stable Diffusion thinks the basics is. Kind of a West Elm laptop desk of some sort. I don't know. That one's a little weird. The first thing you need to know about cloud security, of course, is the shared responsibility model. What that means is that you're pretty much on your own. The cloud providers, they promise to keep things running as best they can, keep the services accessible and predictable, also swipe your credit card reliably. What's up to you is what you decide to put in the cloud, how you decide to configure it, and that part's all up to you. Kind of misunderstood by some folks who aren't security folks, that the cloud really, security is up to you. It's also interesting because instead of IP networks being what passes for authorization, we've got identity. So you'll hear this phrase that identity is the new perimeter. We've been doing the cloud long enough. I think it just is the perimeter now, and it's starting to, the ideas are starting to actually go back into the on-premises. So some interesting stuff going on there. They're constantly rolling out new services. Every time you log into AWS or Azure or Google, what have you, there will be something new there. And IT, or provisioning of systems and resources, is rogue by design. The idea is that a developer can log in, create a system without anybody having to approve it necessarily, and just run it. Or when some new service comes out, just try it out. That is by design. So it gets kind of interesting out there. Here's kind of an embarrassing one. I don't know if it's embarrassing, but Stable Diffusion, when you tell it data sources, actually kind of creates what my slides look like. That's a little weird. But here where my information came from, a lot of it was trade groups. A lot of it was user groups. You'll have everybody has a local cloud user group. I go to those in Austin. I recommend that you try those out if you like. Blogs, tweets, things like that. Also, talk with friends who are less sophisticated about information security. So I've got a little bit of stuff that talks to their needs, and just the school of hard knocks. Just leaving buckets exposed or databases with admin as the access control. Scouring all these different data sources and then putting it together with my experience, I came up with kind of a top 10 list. You can agree or disagree, that's fine. But these were the top 10 things, and I'll talk about them in more detail in a second here. I've got them in order, and I'm going to go through them in order. But that's what I came up with. I've put a question mark after insiders. Like half of all the things that I read said that insider threats are a problem. I put a question mark because I don't know how much that's true. But it's top 10. Lots of people said that's in the top 10, so it goes into the top 10. This is the biggest one, compromised credentials. Would probably happen on premises as well, but on premises just doesn't have the same surface that the cloud has. Compromised credentials are causing something like 80% of the break-ins out there. Password reuse and then being able to stuff that is actually still going on quite a bit. But also one of the interesting gotchas is that tools will cache your credentials. So when you run the AWS command and it asks you to log in, it's going to write that to a file somewhere with your credentials. Makes it real easy if you're hacking around in an environment to find cloud keys, because they will actually be cached. And you can just read them right off the disk. The newer one that's getting attention right now is credentials getting checked into version control. It's actually happening quite a bit, to the point where GitHub now has a bot that looks for this stuff. I've seen a couple of blog posts about, hey, what if I check this stuff in? How long does it take? And both GitHub and Amazon, they were using Amazon, hit them up, emailed, and just said, hey, BT dubs, we noticed that you've got your credentials on there. Sometimes they're checked into version control, and people don't realize that making a new commit without them doesn't take it out of the history. So plenty of opportunities when you're attacking to find cached credentials that you can use. I'm not naming any names, but this was actually how a password manager was compromised. Actually, it was very interesting, and probably most folks know the story, is that a laptop of an employee was compromised. Their penchant for stealing movies meant that they did not update their software and it was vulnerable. Used their master password on their own device. No MFA, got credentials to AWS and downloaded a vault. There also have been cases, there was an interesting one in Google Cloud where somebody checked in their account credentials into Git, pushed it to GitHub. Takes just a couple hours for people to spot it. Most likely it was a bot that spotted the credentials. And the credentials, for some reason, had project admin as their setting. And you can imagine there were coin mining instances pretty fast. It is very interesting to see bots looking for this stuff, because they do find it, and then it's a race. Will GitHub email you first, or will you be mining Ethereum? Enabling MFA is just the obvious simple one. It's just enable that junk. That's key. The way to avoid things caching is try using things like a secret vault. A secret vault will let you store all your secrets securely somewhere else, so that when you run, you borrow credentials from the secret vault instead of typing them in. And secret vaults, they're easy to rotate, so if you have a problem, it's easy to rotate secrets. They're really useful. And then one that's actually kind of a couple years new to me is the idea of canary tokens. There are people out there, Red Canary does it, or you can do it yourself, who will give you credentials that are useless, but that are actually valid for instance, for a cloud account login. And you can put these into your code, check it in, put it somewhere, and see if somebody tries to exploit your cloud with the useless token. And then you know, hey, this source code, somebody flipped it to public, or this guy with the stolen movies used the credentials, or got exploited and somebody tried to use the credentials. So pretty interesting stuff. Did I skip one? No, I did not. IAM mistakes, this happens all the time. And this is because the cloud is really interesting. You'll end up with excessive permissions a lot of times just because folks need to get stuff going. And an asterisk is kind of the easiest way to do it. They do it in development, and then, of course, development becomes production. Other cool thing to read up about if you're still kind of getting out there into the cloud is the fact that cloud resources themselves have an identity and have permissions. So you've got some really cool situations that are exploitable, unfortunately, where, for instance, a virtual machine can make other virtual machines. So that could be the vector in. Instead of compromising somebody's credentials, you could compromise or leverage the role of resources in the cloud. And I mentioned built-in roles because the built-in roles tend to be pretty permissive. If you look at some of them, you'll find that, for instance, there's an Azure identity for that's a reader, but it can read pretty much anything. So because they're built-in roles, they need to be very broad. Unfortunately, folks use them, and they're a little too broad. Plenty of tools out there that'll tell you if you have, if your permissions are too broad. Just got to go search for those. Department of Transportation in a particular state, not this one, did actually have this problem where they had a system that had a vulnerability and some sort of remote code execution thing, and it was actually a virtual machine that was kicking off the other virtual machines to mine Bitcoin. So to defend against this, one of the most effective things is really just to limit down privileges to the lowest you can get, and understand that the perimeter is identity. Is that rather than say this IP can talk to this IP on this port, now in the cloud what we say is this entity can do these actions on this entity. So that's basically the language that you would talk to a firewall. It's now the language that you're talking in the cloud, and it's just not IP anymore. And also, real fun, and actually a great way to defend against this is to borrow red team tools. So use the same tools that other folks are using. There are plenty of scripts out there that will enumerate everything in a cloud account, for instance, or that will specifically probe app permissions to tell you what's going on. Use them. Attack yourself. This one could be ranked higher, cloud misconfiguration. Tons and tons of problems going on right now with people who've misconfigured their clouds. They just don't understand. I mean, it's not anything personal. There's just not a lot of information for non-technical people who are starting to use the cloud. Defaults tend to be pretty insecure. Example code tends to be pretty insecure because the purpose is to hand it off to someone and have things work. You don't want to have a project where the README has like 6 pages of, okay, go through here, add this permission to just this one thing. So these things tend to be pretty open, and then they just say for educational use. The other thing that I see a bunch of is POCs, production on completion, where somebody has tried something in development, it worked, sent it to QA, QA didn't have any tools to check on security, and then it went into production. And in development, the answer to how the heck do I get this to work on the weekend from my home IP address is just open everything. And you will have some curveballs in the cloud world. So make sure to do your homework. Really, that's probably the top thing. But also, infrastructure as code is becoming increasingly useful, and this is one reason why, is that you can actually scan stuff before you deploy it. I really recommend that. And again, red team tools. If you haven't heard of the Bing Bang exploit, it's a very interesting one. We've got Microsoft Azure. They like to talk about security sometimes, but they themselves messed up on Bing itself. And it's just an example of even somebody who works at Microsoft can mess something up royally. What they had done, and this happens in the other clouds too, is they're using Azure AD for authentication to an administrative interface on Bing. And unfortunately, they checked a box that said allow Azure users to log in, not realizing that that didn't limit it down to just their domain. Any Azure user could log in. This happens in other clouds too, where it's ambiguous what it means when it says allow certain groups. Research team found this problem because they were scanning the internet looking for things where they created an AD account just for this purpose. They would log in, have a session in AD, and then just try to log in to all the websites they found that said log in with Microsoft. The admin interface to Bing was open in this way. They were able to log in. They, in what would have made me sweat buckets, changed something on Bing, and it actually went live. So it's funny. The part of Bing that they changed was there's sort of a bar that says good music, good soundtracks or something. Yeah, it's good soundtracks for working to, and they put hackers on the list, and then took it away really fast. Responsibly disclosed, so no problems there. But you can imagine controlling something like Bing is pretty gnarly. Here's a fun one. Visibility is a real problem, and it doesn't have to be. The new services are coming out all the time. So new services, and they are kind of rogue. As soon as you get a new one, somebody can use it before you can even write a policy around it. In the cloud, things are coming and going so fast that often folks won't even bother with EDR or agents out there, and so they don't have visibility there. Sometimes development accounts, people just ignore them, completely ignore them. Leading to some interesting breaches particularly of databases where a developer needed to test some bug in production, so they copied the production database into a development account. Security wasn't watching because it's just development, and away you go. The cool thing about the cloud is your whole inventory is available over an API. So kind of double-edged, it's not really a sword, double-edged Nerf gun. The same way that people can create new stuff all the time, just by clicking something or using an API, you can also list everything using just an API. Beyond EDR I put here because it's real interesting to me to watch what folks are doing out in the cloud, and a lot of folks are leaving EDR off of their cloud resources. For some, it's misguided. They think for some reason there's some magical thing that's watching this stuff. But for others, it's on purpose. If you're using immutable infrastructure, for instance, what the heck is the point of EDR on that thing? It never changes. Maybe monitor to see that things don't change in your immutable infrastructure, but as long as it's immutable, hey, who really cares? And my last advice there is to monitor everything. So please monitor your development environments, because that stuff is going to be production someday. And then, who's heard of shift left? I'd assume a few people. Okay, shift left is an interesting thing. As we adopt more infrastructure as code, or really any code that that decides on resources in the cloud, Docker files, things like that. We're checking this stuff into version control. And if there's something that version control does well that developers have figured out that we should borrow, it's that you can test stuff right when you push it. So developers, I mean, sometimes they won't even know if their code's going to work. They'll change something, they'll push it because they know the automated systems are all going to try it, make sure the functions run, make sure that it's acceptable when it builds things up. Why not throw in a check for security right there? It's called shifting left because we imagine the software development lifecycle going left to right. And the more you can put security on the left in the development area before it's shipping out to production, the better off you are. One problem there becomes 10 in QA, becomes 100 in production. And that, again, that's the power of IAC. My example here is not actually an example, it's just an interesting point, which is that there seem to be attacks going on right now where people are doing coin miners, but they aren't going all out. And they actually are probably using APIs to do all this stuff, and they will kick off 20 instances in each region of a cloud and try to fly under the radar. Number one, because a lot of people aren't monitoring all their regions. Number two, because it's just not that big of a hit for the cloud providers to email you and say, dude, your usage just went like that. Definitely monitor everything. I've seen too many people who monitor only the region where they're supposed to put stuff. And so if you have 20 instances being kicked off in regions that you didn't use, and you're not monitoring them because you figure you didn't use them, now you're in trouble. So keep an eye on that. This is a fun one, probably not entirely a cloudy kind of problem, but it seems to be happening more in the cloud as people go to microservices, things like containers, things like serverless functions. APIs have just been ignored for one reason or another. And the thing that comes up the most is broken authentication. They just don't do authentication right, usually because they try to invent it themselves. But also there's a distinct complacency that they have things behind a firewall, and so it must be safe. And the problem is things like broken authentication aren't something that a firewall breaks. You logged in successfully, okay, great. You logged in as somebody else, how does a firewall know? It doesn't have access to that database. It can't check your authentication. And this is another case for sure where development becomes production. And one of the cool places where I see it is a developer will just write a serverless function to check some metric on some resource that they have in the cloud. And they use it, they hand it off to their friends and say, hey, you can use this too. And then suddenly it becomes production because some business application starts to use it. So microsegmentation is a good defense against that. If you know each piece in your distributed application, you can segment it down and say, this thing should only ever get these API calls. It should only ever see these endpoints, and it should only take these values of these types. And one of the cool ways to do that that's kind of emerging these days is policy as code, which at the most basic you can think of as, I've got some infrastructure as code, I've got some Terraform maybe. I'm kicking off a couple of systems so that I can deploy code to them. Why not configure the access control list on the firewall at the same time? I'll just put that into a file, check it into version control, and now it's versioned, it's predictable. I can scan it with tools, tons of tools. I think it's the way of the future. I'll be in the hallway if anybody wants to beat me up. Behavioral analysis is really useful too. Starting to see a few companies come out that watch your APIs and figure out how they're supposed to behave, or at least what's expected of them, and then flag things that deviate from that. An example of this, and in fact, I couldn't name the company for telco APIs because too many of them have had the exact same problem, is and authentication that was broken. That similar to that Bing Bang thing, all they were checking was that you're logged in. They didn't really care who you were. And so we've had a couple of telephone companies now where somebody watched the traffic coming off their mobile phone and then just decided to try some stuff. Figured out that user IDs were sequential, made the same call to find the balance on their bank or to find the balance on their mobile account, and just incremented their user ID, and they got data back. There was an Australian telco, in fact. The 9 million records were leaked, which is kind of fun when you consider that Australia only has 27 million people. So, lots of people getting their identity protection for free there now. This one comes up a ton, external data exposure. Comes up in a bunch of flavors, too. You will find, unfortunately, a lot of people leaving their storage buckets open because they just didn't know any different. The cloud providers are getting better about spotting this and warning you before you do it. When you create a bucket and you say make it public, they kind of say, are you sure? Because usually you're not sure that you want to do that. But again, sample code, things like that, they'll just say throw a star in, it'll work. Don't do it in production. There also, you'll find that with more and more, like for instance, SaaS products that can do things for you in the cloud. In your account, you now have cross-account permissions. You'll want to take a look at those and make sure that you're at least monitoring what your partners are doing. I think that was one of our telcos where it was a third party had access to do whatever kind of API calls they wanted, and data got exfiltrated through the side door that way. And this does come up from default configurations. The default configurations just make it easy, throw a star in. Examples, there was an adult cam site that got hit back in the days, well, I think it might still be the case, when Elasticsearch didn't have any passwords on them. A lot of databases do that because they're just internal. So you don't want to deal with authentication. If you've tied down your identity-based authentication or authorization enough, it's okay to do that. But they left an Elasticsearch open and everything went. But also I have a friend named Pete. When I was talking about this with him, and he's not in anything, he's a lawyer. And he said, yeah, we got hit by ransomware, I think was the problem, in the cloud. And he looked at me and he was like, I don't know what happened. I mean, isn't the cloud supposed to be secure? And I said, well, yeah, kind of, but how you configure it, they leave that up to you. And so, like, nobody's telling anybody about the shared responsibility model. They're just saying things like reliable, predictable, easy to use. They're not saying completely and utterly insecure if you don't tie it up. So Pete got hit. Here's one I want to put a question mark after, but I also kind of don't. Because once I started to look it up, increasingly sophisticated attacks turned out to not be entirely vendors trying to scare the heck out of you. There do seem to be some more sophisticated attacks. This could be an entire talk, so somebody should do some research and put in a talk for next year. What's going on from my vantage point is that there's kind of a price war going on for stolen information. You can get skimmed cards for a couple bucks, like $10, depends on the balance. You can get fulls on people, depending on the country, for like $20. And that means that at that scale, there's no value in exfiltrating one record, or even maybe 1,000 records. All that work, you want to exfiltrate a ton of records because they're worth so little that if you're going to have a payday, you have to have a whole ton. So it's leading to things like spear phishing. And no, ChatGPT is not going to change that. Again, hallway, you can beat me up out there. One of the really cool things that's going on is adversaries are using APIs too and automating. So that 20 nodes in each region attack, I am pretty darn sure that it is API-based and scripted. Yeah, and ChatGPT, I don't think that's going to be a problem yet. One of the interesting, sophisticated attacks that's now been proven is that speech authentication can easily be broken, particularly by deepfakes. This was supposed to be a silver bullet for the banking industry, and they just relied on it, and now it's broken. There was a story on the BBC about a bank where they swore that their voice authentication would never let two people log in as the same person. And the BBC found a pair of twins, interestingly enough, fraternal, not identical, and had the one try to pretend to be the other. And it actually ended up working. To be fair, they did have to try 8 times to do it. But to be also fair, the bank shouldn't have allowed 8 tries. So that's kind of on them. Behavioral analysis is, again, really useful, is to be able to track what people do and then see where they do it. You know, the same way that when you get here and you check into a hotel, maybe because you're from Austin, and you sign on with your Okta or whatever, it says, man, what the heck are you doing in Nebraska? That's the kind of stuff that you really want, is to be able to analyze behavior that way. I think also adversaries are automating, so we need to automate as well. Automatic remediation is something that you can do. It's not as scary as it seems. And you can, of course, have human intervention before you do things. But if you've got tools checking on, for instance, your permissions and stuff, why not automate the rest of it to say, hey, push this button, and we'll take these permissions out for you. Cloud's all an API, so you can do anything you want there. You don't have to screen scrape or anything. And then, unfortunately, patching has to be on this list because people just don't patch. It's really insane. As somebody who gets to see people's environments and see what vulnerabilities are on workloads, it's amazing to me that Log4Shell is still out there all over the place. That's an example that I had from Microsoft. Just published a blog on this, so I don't have it in my notes. But they've seen some attacks, some sophisticated attacks coming through just using Log4Shell. You look at ESXi servers out there; they're just sitting ducks, and people aren't patching them. So, kind of go back to that slide about visibility. Get some visibility out there. I don't know how I feel about the insider threat, but the industry and the scaremongers feel like it's a really big problem. What I would say is that probably the biggest part is people who are just curious about stuff, and so they'll do things inside the environment at work that they shouldn't do. They're aided by excessive permissions and by lack of logging. Now, the cloud's pretty awesome because we can log everything. And excessive permissions, we can take care of that with just a little bit of work. So it's not as bad as you might think. Got to put social networks in here because those are really the fun ones that are showing up in the news, where insiders they have too much permission. They're able to read other people's posts, and they do. Not a social network, but look up that latest Tesla problem too, where employees were tapping into the cameras on Teslas and then posting internally funny, America's funniest Tesla videos. Way too much permission out there for what people need to do. Go with the least privilege attitude. I keep saying behavioral analysis. I wonder if I just copied and pasted that. But it is very important. Knowing who accesses what and then spotting when they access something else, that's just incredibly useful. And there's so much information and so much going on in the cloud that you really do need to let a machine do it. This is really a job for robots. Background checks. You would think people would do background checks. Apparently they're getting really cheap ones. Not necessarily a cloudy thing, but system vulnerabilities do happen. And a lot of folks who are using the cloud, it's not their job to worry about vulnerabilities on the system. They created an EC2 instance from the Amazon Linux image. They just assume it's got to be secure. You know, of course they patched it before they made it golden, but they didn't. So for some reason, folks just don't do patch management in the cloud as well as they do on premises. So I would encourage you all to think about how you do that, because there will be base images that are just garbage, but you got to use them, so you use them. This one, this is definitely where things like unpatched ESXi servers and Log4Shell come in. It's unbelievable that these are still problems at this point. Get some visibility and get buy-in. That's really essential, because you're going to have to ask for somebody's time to go out and look at the state of patches out in the cloud. That's going to take somebody's time, and there are going to be a lot of people like Pete who say, I thought the cloud was secure, and you're going to have to get some buy-in there. And patch. Controversial, I don't know, but there's a lack of people willing to say that they have cloud experience. That's what I'll say, is that everybody's got to start somewhere. It's hard to find seniors because this stuff is brand new. If there's a senior out there that you want, you might not be able to afford them. There is a shortage in cloud skills, but I do think part of that is just folks are hesitant to say they know something about the cloud, or to say to their boss or an employer, to say, yes, I know one cloud, I should be able to transfer it to other clouds, and take that chance. Because some bozo is going to say they know every cloud. We all know that. And the tooling for the different clouds is all different. The clouds do things in subtly different ways. So there is a bit of a shortage. And if you do know, for instance, all of Google, it is transferable, but you're going to have to do some work to figure out the other clouds. But if you got a good boss, they're going to be cool with that. My example is just whining CISOs. There are probably too many to number. So, this is a review of the top 10 right here. But my advice, let's see, where to start? Looks like I've got an old version of my slide. Where to start is really to get some visibility. You need to know what you've got out there. Plenty of ways to script it. Everything's an API, so it's easy enough. There are other tools that will use the same APIs to give you visibility into what sort of information is out there. It's a real, if you want to start a company, figuring out how to deal with data security is a really useful place to start. If you could figure it out, you'd be rich. As it is, cloud providers will do it for you and charge you an arm and a leg for starters. And you can also, so sometimes you'll find that sampling is useful enough. So a good place to start is to just use your visibility to list all of your storage, all your databases, and then just poke a little bit and see what you can find. It's easy enough to script something that hits storage endpoints and just says, if I get back an XML document with more than 5 items in it, I probably found something And so I'm going to go take a look at that. You don't have to get that fancy just to get started. I'm going to bring this up so that I can work off it as well. Learn about identity. It's totally different in the cloud, especially with resources having their own identity and their own permissions. It gets really wacky, and you can misconfigure things. Watch for those APIs. Getting started with API protection, I would say probably comes down to one of the fun things you can do is create a capture the flag sort of situation or hackathon, probably some combination of those, and get folks together to just look at the APIs that you've got and try to break them and have some fun. I've seen some pretty good experiments where folks have set aside a Friday and had developers and InfoSec, their DevOps folks, just come together, get a bunch of pizzas, and see who can break what, and have prizes for whoever can break something first, or who breaks the biggest thing. Real easy to do. Just get a fuzzer as a start, and then go from there. Getting started with data exposure, sampling is a good way to go. Those sophisticated attacks for that talk that one of you is going to give next year, you could do it. No? Okay. There's nowhere to get started on that other than to go back to my encouragement to have some behavioral analysis. Those are tricky. There's not so much open source, especially for specialized behavioral analysis of things like identity, things like database access. So, bit of a tricky one there. I will say I don't like the whole idea of insiders. You're probably more likely to have somebody compromise an insider's credentials. If that counts as an insider attack, that an insider's credentials did it, I would say yes, insiders. And the place to get started again is watching the behavior of your systems, and then also locking things down into a least privilege. And there they have plenty of open source. I thought the first person to fall asleep during my presentation would be over the age of 18. No, right there. That's okay. Go to sleep. I love this conference because people bring their kids. It's so cool. I really like that. Vulnerabilities you're already started on. Getting started there, not a problem. The real getting started there is start doing it in the cloud. And for talent and skills, getting started there is going to your boss and saying, hey, I want to spend 2 hours every week doing something. Going through, cloud, there are cloud vulnerable architectures that you can download as Terraform and run. It's a good place to get started is to just mess with stuff a little bit. Figure out where it's going to be valuable so that you can tell your boss, hey, look what I did, or so that you can tell your next employer, look what I did. And that's really pretty much it. That's my top 10. That's where to get started, and I hope it's been useful. Are there questions? Yeah. Is there a cloud provider that does security better than the others? No. They're all pretty bad. And it's on purpose. Because if Pete, for instance, who had his ransomware problem, if he had some defense against that, but not full defense against that, he's going to blame the cloud. He's going to say, hey, you said you were going to secure this, and you didn't. Plus, the cloud providers, there's way too much money to be made in selling solutions to the problem they created. So that's what they're doing. It's really interesting to me to look at the stuff coming out of the federal government right now around cybersecurity and around how we need to really improve it. because one of the things that they're starting to say, apparently people did not buy the right Congress people, is that providers need to start securing stuff. Software developers need to start securing stuff. That it's not my responsibility. Like, if a wheel falls off my motorcycle, unless I was the one working on it, it's not my fault. If you get 20 Bitcoin miners in every region you're not using, it's apparently your fault. And so, no, nobody really does it better than others. Yeah, what else? Yeah. Ooh, interesting. Mm-hmm. Yeah, the question is, should we be, since we can log everything in the cloud, should we be putting those logs somewhere separate from the accounts that we're protecting? I like that idea. It'll be a little extra work, but it's not too bad. For instance, I can imagine creating a storage bucket over in its own dedicated account and then granting permission to write to it from the logging tools in my main account. Not that hard to do. Your security tool, when you do it, your security tools that you're using should flag it, and they should say, hey, man, there's external access to write to this bucket. If it doesn't, go get a new tool. But I love that idea, yeah. 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 Yeah, is there a connection between data science and CloudSec? I sure hope so. Probably for my own reasons, I find that stuff really fascinating. But there has to be, because it's at such a scale that there's no way for a human to do it. It's long gone are the days you come in on Monday and look over the logs and see what's happening. There's just so much going on and so much sneaky stuff going on. Yeah. Yeah, you bet. What else? Yeah. Mm-hmm. A good resource for getting started playing. Not really. Anything that has Terraform is going to be a good start, because then you can just run it, and then you can go back and look at it and figure out where the problems came in. It's a very good skill to know about infrastructure as code as well. I would just do some searches out there. Look for Cloud Goat. So similar to OWASP's Web Goat, there are several projects for Cloud Goats that are just insecure by design. That's probably where I would start, is with a search like that. What else? All right. Well, that's my time. Oh, then you got. Responsibility matrix. Where'd you find that? Oh, they do? Okay, interesting. That's a very good point. Every cloud provider has a responsibility matrix. And read it, because it'll tell you exactly what's your problem and what's their problem. And then also double check on their problem. Because even Bing was having trouble. All right, that's my time. I thank you very much for showing up.